morning, students. In this lecture, I am going to discuss non-homogeneous linear equation. Or students, non-homogeneous linear equation. Right now, students, non-homogeneous linear partial differential equation with constant coefficient. This is the topic, students, today. Non-homogeneous linear partial differential equation with constant coefficient. In the last class we discussed, students, in previous classes we discussed homogeneous linear partial differential equation with constant coefficient. Now in this lecture, non-homogeneous. What, students? Non-homogeneous. What is non-homogeneous, students? What is non-homogeneous? Non-homogeneous order is not same. Non-homogeneous means order is, partial derivative order is not same. Right. If, right now, students, if in the equation, what is the equation, students, previously? Very good. F of d comma d dash into z, that is equal to f of x comma y. F of x comma y. Now, the polynomial expression, what is polynomial expression here, students? F of d comma d dash. F of d comma d dash. It is not a homogeneous equation. It is not a homogeneous function. Not a homogeneous function. It is called non-homogeneous linear equation. Non-homogeneous linear equation. Once again, students, everybody know f of d comma d dash into z is equal to capital F of x comma y. Here, f of d comma d dash is not a homogeneous. Then the given equation is called non-homogeneous linear partial differential equation. Generally, we are discussing, students, here with constant coefficient. What, students? Non-homogeneous linear partial differential equation with constant coefficient. Here also the complete solution same, students, as we learn in homogeneous equation. What, students? Complete solution. What is complete solution, students? Complementary function. Complementary function plus particular integral. Simply it is denoted by, students, complementary function, that is equal to c dot f. C dot f means, students, complementary function. P dot I means, students, here particular integral. Now, there are some rules, students, for finding complementary function. Rules for finding complementary function. Previously, we have factor, students. What is factor form, students? Previously, we have homogeneous d minus md dash, students. Previously, we have the factor form d minus md dash. D minus md dash. Now, here f of d comma d dash can be resolved into linear factors. Or students, previously we have d minus md dash students. Now here we have d minus md dash minus c1. Say this is m1. What students factors form here? This is very important students. What is factor form here? D minus m1 d dash minus c1 into d minus m2 d dash minus c2 and so on. This f of d comma d dash can be resolved into linear factor students. What is the factor form here students? D minus m1 d dash minus c1, d minus m2 d dash minus c2. The factor must be in the form d minus m1 d dash minus c students. What is factor form here students? What is factor form? D minus md dash minus c. What is extra term here students? Minus c. What is extra term? Minus c. Right? Then complementary function as follows. Actually, we can apply here Lagrange's linear equation students. By applying method of multipliers or method of grouping, we can find the solution students. But I want to discuss directly the complementary function, the solution students. Right? Roots, complementary function. First one is, suppose the roots are, these are the two roots students. Suppose, for example, d minus m1 d dash minus c1 d minus m2 d dash minus c2. Suppose repeated root students, distinct roots, different roots. In this case here, the complementary function is e power, what is the constant here students? c1x f1 of y plus here m1 here students. So m1x plus e power, here we have a constant is c2x f2 of here m2 here students, m2. So m2 means y plus m2x, Suppose repeated roots. Suppose d minus md dash minus m1 d dash minus c1 into d minus m1 d dash minus c1. Two roots are repeated students. Then here e power c1x is common. C1 is common. So e power c1x into f1 of y plus m1 also 7 students. m1x plus, count me here students. Very good. Here you write here x f2 of y plus m1x, bracket close. When repeated, two roots are repeated, the factors are same students. Then e power c1x f1 of y plus m1x plus x into f2 of y plus m1x. This is about complementary function students. Let us see the rules for finding particular integral. Write students, rules for finding particular integral. Rules for finding particular integral. Here also, what is equation students? F of d comma d dash into z, that is equal to f of xy. Based on this the function f of xy, again we discussed 4 cases students. 4 cases here also, as we discussed in homogeneous linear equation. What are the function students? Exponential function e power ax plus by. trigonometry function sin ax plus by or cos ax plus by. And third one x power m, y power n. And fourth case is f of x, y. Here the fourth case may be changed, students. Fourth case may be changed. That is the combination of e power ax plus by and v of xy, students. V of xy. It may be case 1, case 2, case 1, case 3. Okay, students, like this. Right. Case 1. Case 1. If f of xy, this one f of xy, that is equal to e power ax plus by. E power ax plus by. What is particular interest, students? Same, students. F of d comma d dash into e power ax plus by. That is equal to same. What is, students, here? Replace d by a. That means we get f of a comma d dash by b. We get here particular integral. This is the particular integral. Now provided here f of a comma b is not equal to 0. Or students, f of a comma b is not equal to 0. Note. If f of a comma b is equal to 0, students, f of a comma b is equal to 0, then differentiate. What, students? Differentiate denominator with respect to capital D, students. What, students? Differentiate the denominator with respect to D and multiplied by x. Now see, students, here f of a comma b is equal to 0, then differentiate denominator with respect to d. For example, here 1 by d plus d dash, students, d plus d dash. What I am saying here, differentiate with respect to d, students, d plus d dash. Then what we get here, students? Come on, tell me. We are differentiating with respect to d, students. So the derivative of d is 1. This is the constant, students. Whenever we discuss, whenever we differentiate with respect to d, d dash is constant. So the value is 0. Finally we get 1, students. Like this. Okay, students. Now case 2. What is case 2, students? Case 2, if f of xy, that is equal to sin ax plus by or cos ax plus by. What, students? Cos ax plus by. What is particular integral? 1 by f of d square comma d dash comma d dash square, students, into, say, suppose sin ax plus by. Sin ax plus by. So that is equal to d plus d square by minus a square, students. So we get f of minus a square, d dash by minus ab, and d dash square by minus b square into sin ax plus by. Or, students, sin ax plus by. And provided here f of minus a square comma minus ab minus b square value, students, not equal to 0. Not equal to 0. Same, students, here also same. What is that? If f of minus a square minus ab minus b square value is equal to 0, then differentiate, same, students, differentiate denominator with respect to d, students, and multiplied by x, students, multiplied by x. Now case 3, students. Case 3. What is case 3, students? If f of xy is equal to x power m y power n students. Now what is particular integral? Particular integral 1 by f of d comma d dash students into f of xy. How many students here? You can write this as f of d comma d dash whole power minus 1 f of xy students, f of xy. Now we expand this students, expand f of d comma d dash whole power minus 1 in the ascending power students, ascending powers of d or d dash students by binomial theorem, binomial expansion, operate and then operate on x power m y power n term by term. This case is as it is students, as you done in homogeneous linear equation. See students, once again f of d dash whole power minus 1, I am applying binomial expansion here. What is binomial expansion students? Once again 1 minus x whole power minus 1, then I can write here 1 plus x square plus and so on. If it is 1 plus x whole power minus 1 students, you get alternately plus minus. So 1 minus x plus x square minus x cube plus and so on students. I apply that binomial expansion here students, either in terms of d by d dash or d dash by d. And then I operate on, where I am operating students here? F of xy. What is f of xy here students? What is f of xy? X power m y power n students. X power m. I am operating on x power m and y power n students. Then you got the required particular integral. Right. Now what is case 4 students? Case 4. Here f of xy is equal to e power ax plus by into v of xy students. What students? E power ax plus by into v of xy. Of course we know what is case 1 students? E power ax plus by, so it's same. And we have a function. The notation is changed students here. V of xy. Previously we have f of xy. Here we have f of xy. Now the particular integral 1 by f of d comma d dash into, write the students, e power ax plus by into v of xy. That is equal to, now you write here students e power ax plus by left hand side, and then you write students 1 by y, once again students, you write left hand side of this 1 by f of d comma d dash students. That means you get e power ax plus by. Now you replace here d by d plus a comma d dash by d plus b. Okay students, replace d by d plus a and d dash by d plus b into v of xy, or students into v of xy. Okay students, if it is sin ax plus by, we know how to find the particular integral. If it is v of xy is x power m y power n, we know how to find particular integral students. Okay students, one second case 4 is 1 by f of d comma d dash e power ax plus by v of xy. You write e power ax plus by left hand side students, left hand side of 1 by f of d comma d dash, and then you replace d by d plus a and d dash by d dash plus b into v of xy. If v of xy is trigonometric function, we know the procedure. If it is a x power m y power n, we know the procedure to find particular integral. Okay students, this is the concept of non-homogeneous linear equation. Okay, hope you understand. Thank you for watching this video. Jai Hind.